MCV4U, first lesson of Unit 4 on curve sketching is increasing and decreasing functions, and I don't think you're going to see anything that's too surprising today. One reminder is the way things are, the pecking order, the way it's supposed to be in these things, is you are supposed to have done the warm-up already. It's not, this isn't just another example you're copying down. This is actually to get your brains on what we're doing, or another chance at what we did yesterday. So please do the warm-up first. If you have not done this warm-up yet, stop this video now and try it on your own. Then of course you do the note in the video, and then the homework is for class, right? That should be done already. Now we're going to do that, and this is for later. So we have S at t is the position function for an object. What do the following tell you? So this is just a straight interpretation thing. So S at 5 equals 3. Well, remember, if S is the position function, a positive value means it's to the right or up or whatever is in the positive direction. So after 5 seconds, it's right 3 meters. The object is right 3 meters. The first derivative at that point is the velocity, right? So the velocity is 6, and because it's positive, that says that it's moving right. That the distance from the origin is increasing, moving right. But at 8 seconds, it's moving left. And then if the velocity is 0, that means it's stopped, right? Stopped at time equals 6.5 seconds. What I wanted to point out here is that if I plot that on a sign chart or a number line here, after 5 seconds, this is 6, which is positive. 6.5 seconds, this isn't to scale, it's 0. And after 8 seconds, it's negative. Now, it's possible that there could be some goofy things happening here. We don't know what S looks like, but generally, what we've got here, if as long as it's nice and smooth, we've got it's positive there, negative here, and 0 somewhere in between. So notice the velocity is positive, 0, negative, or the function is increasing, 0, negative. So what does it look like is going on at t equals 6.5? It appears that it has a maximum, right? Has a max at t equals 6.5. We don't know that. It could be that it wobbles back and forth a few times in here, but that seems to be the picture so far. So positive, 0, negative, it looks like it has a maximum. And that's just looking at the first derivative. Here's another function, and this is some practice on intervals. And notice the increasing intervals I put all in, this is interval notation and this is in set notation, and I don't care which you use. You shouldn't mix up the two, probably. That's somewhat confusing if you do that. One thing I want to mention here, this function does something weird. It's increasing, it looks like all the way along here, but it looks also that it kind of evens out at x equals 1. So at x equals 1, is it increasing? No, it stops for a little bit. When it stops, the rate of change, the first derivative is 0 there. And so that's why x equals 1, we left out, because it stopped increasing. It was 0 just for a moment in time. And then it decreases only on these two chunks here, right? It's going down, going down. And the big story today is it's increasing if f prime at x is greater than 0, and it's decreasing if f prime at x is less than 0. That's the big story today. So like I said, not that surprising. Increasing, first derivative is positive. Decreasing, first derivative is negative. And I think if I asked you, you would have told me exactly that. So points where the derivative is 0, though, it's where it's neither increasing nor decreasing. Critical points, or rather turning points. And that's not really a turning point, but there's something going on there. But we can see there, there, and there. Three spots where the first derivative is 0, but also there's some weirdness at um, f at x is undefined at 2 spots as well. And that's the story for that. Let's get into today's stuff. Increasing and decreasing functions. So our expectations today are to make connections between increasing, decreasing intervals of a function and the first derivative. Well, I kind of spoiled that, didn't I? Well, I'm hoping that you knew this already, or at least you pressed for an answer. You would have guessed this. So here we go. F is increasing on an interval if for x1 is less than. By the way, this is kind of a almost like a formal definition of what increasing means. You know, goes up is what increasing is, but that's not very mathematical. So this is a mathematical definition. Is increasing on an interval if for x1 is less than x2, x1 is less than x2, f at x2 is greater than f at x1. As long as I'm reading x values from left to right, that means f2 is f at x2 is bigger than f at x1. It's going up. And it also means the first derivative is positive. Opposite for f being f decreasing, right? If I'm reading x values left to right, that's what this means. Reading x values left to right, as long as f at x2 is less than f at x1, then it's decreasing. It's going down. And that's for any values of x1 and x2 we pick that meet these criteria. The first derivative is negative. And these are things I think we kind of observed as we were working our way through derivatives, but it becomes very formal in this chapter. But not really new, I don't think. So here we go. We've done sign charts before, so we're asked to do a sign chart. So given y equals f at x, give a sign chart. Okay, what do we mean? Well, first of all, we usually, what color do I got going right now anyway? Purple? Okay, I'm going to make my line purple just so it matches. Why not? Why not? Okay. And so the first one, by the way, is not that interesting. If I just talk about f being positive or negative, I can kind of read that right off the graph, right? It's easy. It's 0 at 1 and 3, negative in between there, positive on this side, and negative, positive on this side, right? So the function y equals f at x is positive, 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 0, negative, 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 0, positive, positive. And that's just the function itself. What's more interesting is what happens to the derivative. Well, let's identify where the derivative is 0 first. Well, where is the derivative 0? It's where it would have a horizontal tangent right there. So at 2, this thing is 0, right? Right there is where I would get my horizontal tangent. And then on the left side, that's where the function is decreasing. So the first derivative would be negative. And on this side, it's increasing, so the first derivative would be positive. Decreasing, increasing. By the way, this is A. Now we're asked to sketch y equals f at x. All right, well, get some colors going here. Try and match it up. So if this is going to be y equals f prime at x, the derivative function, well, where is it 0? So it's 0 right there at 2. Right, that's 2. And then on the left side, f prime at x is negative. So it means on the left side, it's negative. But on the right side, it's positive. So this is y equals f prime at x. Notice that makes sense to us because this is just a parabola. We take the derivative of a parabola, we get a linear function of some sort. And you notice, if we wanted to, just for funsies, we could keep going, right? If I wanted to, we need a little more room here. What would I think about f double prime at x? Well, f double prime at x, if I took the derivative of this, sign chart, should be using a ruler, where is the first derivative reach a maximum or a minimum? Nowhere. It's always positive, right? This is the derivative of this is constantly positive. Like this, and what would its graph look like? A sketch of this derivative would look like a constant positive function, right? Yeah, absolutely. And so this idea of the sketch of a function and then its derivative and then its derivative. Um, and don't get them mixed up. Remember, even though we talk about the derivative as the rate of change, they also become a new function of their own right, right? We didn't have the formula here, but that'll do. How are we doing for time? Time for a break. We'll bring it back with example 2 and maybe example 3 in the next video.